Welcome back to Precalculus, folks. Today we're in Chapter 4, Section 3, talking about logarithmic functions. So before we start talking about logs, let's first review an exponential. Okay, so our first example, we're going to start off with the exponential 3 to the x. Okay, so if we just simply want to go through and graph this, we know that we're going to have a horizontal asymptote at y equals 0, and then we're going to have a table of points. Okay, so 3 to the negative 1 is 1/3. Anything to the 0th power is 1, 3 to the first power is 3, and 3 squared is 9. Okay, so if we go to graph that, it should look very familiar. A little bit like this, and so on. Okay, now to find the inverse of this, we know that we're trying to find the inverse here. We're going to use this table. We know that we reflect over the line y equals x, so I'm going to go ahead and draw the red line y equals x that we can reflect it over. Okay, so first things first, if we reflect a horizontal asymptote over the line y equals x, if the y becomes the x, then now we're going to have a vertical asymptote. Okay, and then with the table of points, all we have to do is flip our x's and our y's. So this is going to become 1/3 negative 1, 1, 0, 3, 1, and 9, 2. So let's go ahead and graph that right now. So 1/3 negative 1 is about right there, 1, 0, 3, 1, and so on. You see that we have about that curve right there. Now, if we were trying to find the algebraic expression for the inverse of this, so first we would change it to y equals 3 to the x. So if we're trying to find the inverse of y equals 3 to the x, we need to change it to x equals 3 to the y. And now we kind of get stuck because there's no way to solve for y. Okay, we can't take like the y-th root or anything like that. So because we cannot solve for y here, we have an expression that represents the solve for this, okay? And that is called a logarithm. So by definition, y equals log base b of x if and only if b to the y equals x, which you see is what we have up here. Okay, so the inverse of an exponential, okay, the inverse of this exponential is what we define as a logarithm. So what you're looking at here is a graph of a logarithm. So to summarize the graph of the logarithm, let's revisit the graph of the exponential and we'll compare. Okay, so exponential log. Okay, an exponential has a horizontal asymptote at y equals 0. So its inverse is logarithms. We're going to have a vertical asymptote at x equals 0. And we're obviously going to slide these things around. Okay, an exponential has a y-intercept of 0, 1. So a logarithm is going to have an x-intercept of 1, 0. And lastly, an exponential, when you plug in 1, you get out the base. So when you plug in the base into a logarithm, you're going to get out 1. And we'll play with that more and more as we see what a logarithm is. In general, if you understand that a logarithm is simply an exponential, you're going to be way ahead of the curve there. Pun. So let's go ahead and slide down and take a look at a couple examples here of logarithms. Okay, so here we have log base 3 of 9 is equal to 2. So if we use our definition, log base 3 of 9 is equal to 2, we can rewrite that as an exponential. That means, I like to think of it like this, like the 3 goes underneath, boom, and 9 is equal to 3 squared. If we look at the next example, again, the same thing. 5 goes underneath, pops up on the other side. 5 is equal to 25 to the 1/2, which is true because 25 to the 1/2 is the same as the square root of 25, and we know that's equal to 5. So now let's go backwards, still using our definition of a logarithm. Okay, here we have 10 squared equals 100. Well, if 10 squared equals 100, then that means 2 is equal to log base 10 of 100. The base of the log is always the base of the exponent. Okay, if we have 3 to the negative 2 equals 1/9, then that means negative 2 is equal to log base 3 of 1/9. Okay, now let's take a look at some very common logs used. So first things first, if you ever want to write log base 10 of x, we don't need to write the base 10. So like on your calculator, when you see log with no base, that means log base 10. Okay, log of x is the same as writing log base 10 of x. Log base e of x, okay, we rewrite that as the natural log of x. We call it the natural log because we use the natural number e. Okay, let's take a look at some solving some logarithmic expressions without a calculator. So we have log base 3 of 3 is equal to something. We don't know what it's equal to. We don't want to use a calculator. Okay, so I'm going to put a little question mark right there. Well, remember, a log is an exponential. So if I go underneath, 3 is equal to 3 to the what power? And that should be telling you 1. 3 is equal to 3 to the first power. Okay, let's take a look at the next one. Log, oh, we don't have a base here, so I'm going to write it in. When you don't have a base, you can assume it's base 10. Log base 10 of 1 is equal to what? Well, convert it to an exponential. Okay, so 1 is equal to 10 to the what power? Hopefully you said 0. Anything to the 0th power is always equal to 1. Okay, now let's take a look at the next one. Log base 16 of 2. We don't know what that's equal to. But let's convert it to an exponential. To solve a logarithm, can always convert to an exponential. So 2 is equal to 16 to the what power? Now you're going to have to remember your rational exponent properties here. But 2 is equal to 16 to the 1/4 power. And for our last one, let's take a look here. The natural log of e cubed. Okay, well we know natural log, I'm going to rewrite that just so it's a little easier to see, is the same as log base e of e cubed. We don't know what that's equal to. Well, let's take our base, bring it over to the other side. So we got e cubed is equal to e to the what power? Should make sense. It has to be 3. Now for solving the next ones, you're simply using a calculator because these are not going to be easy exponent solves. I'm just going to do it on the screen for you here. So log of 3, our log button is right here. Log of 3, and we see we get 0.477. Okay, if we wanted to take the log of 32, same thing, 1.51. Strongly encourage you guys to try this out on your calculator. Make sure you know where the buttons are. Okay, natural log also has its own button. It's right here on the left side. Natural log of the square root of 5. .805. And the natural log of 7.3, 1.988. Easy peasy. So now let's take a look at graphing some logs here. Okay, so we know if it's a logarithm, it's going to have a vertical asymptote at x equals 0. So I'm going to go ahead and draw that. It's got a vertical asymptote at x equals 0. Whenever I plug in 1, I'm going to get out 0. So the point 1, 0, all I'm doing is referencing this table right here. And whenever I plug in the base, I'm going to get out 1. So whenever I plug in 2, I get out 1. And there's the shape of my log. Okay, same thing's going to happen in this next example. Okay, we've got a vertical asymptote at 0. If I plug in 1, I'm going to get out 0. And if I plug in the base, I'm going to get out 1. So if I plug in 1/3, I get out 1. And what that's going to do is it's going to flip the shape of my log. Simply because the base is between 0 and 1. Awesome. So let's jump on down here and take a look at the next one. Well, the first thing I want to do is I want to graph just log base 3 of x. And then we'll slide it left 2 down 1. Okay, but if we just draw log base 3 of x, we know we got a vertical asymptote at x equals 0. Got a point 1, 0. And a point base 1. So 3, 1. So draw it nice and light and dotted. Now we need to take all those points and slide them to the left 2 down 1. Okay, so first things first, our vertical asymptote is going to go left 2. Doesn't necessarily need to go down 1. And all our other points are going to go left 2 down 1. Left 2 down 1. And in my solid black, you can see my final picture. Okay, for this last example, it looks a little bit funky. Okay, but I'm just going to rewrite it so that the x comes first. So first things first, this is log base 4 of negative x plus 2 plus 3. And if you remember back to your graphing days that you want the coefficient on the x to be 1, so we got to factor this negative sign off, but it can't leave the parentheses. So this is going to become log base 4 of negative, and then we got x minus 2 plus 3. So we can see that we actually have a right 2 and up 3, but first we have a reflection over the y-axis. So as always, let's just start off by graphing log base 4 of x. So vertical asymptote at 0, x equals 0. A point at 1, 0, and a point at base 1, so that would be 4, 1. Let's draw it nice and light. Now we're going to take our points, our 2 points in our asymptote, and we're going to reflect them over the y-axis, right 2, up 3. So let's do the asymptote first. The asymptote's on the y-axis, so when you reflect it over the y-axis, it's still there. Right 2, up 3, really just right 2 is what we care about. Now let's take this point right here, this x-intercept. Always reflect before you do anything else. So reflect it over the y-axis, it'll be right here. And then right 2, up 3, it's going to be right there. And lastly, let's take this point at 4, 1, reflect it over the y-axis. So now it's at negative 4, 1, right 2, up 3. It's right there. And the shape of our logarithmic graph should represent a reflection over the y-axis. So if you have any questions, please bring them to class. I look forward to helping you guys. Have a good day.